All right. Happy Thursday. I wanted to talk to you about lesson 4.2. This is your homework that you did last night, solving systems using substitution. So I asked you all to skip number 1. I'm going to start with number 2. So for number 2, I solved equation number 1, or equation number 2. I got x all by itself. So for equation number 2, I got x all by itself. That's what this is right here. You see x equals 2x plus 6. It's my pen. X equals 2y plus 6. So then I took that expression for x and I plugged it into equation number 1 right here. I had to distribute and then simplify, and I found out that y equals 3. That's my first solution, y equals 3. So then I took the y equals 3 and I plugged it right back in to equation number 1. Put it right here. And I find out that x equals 0. So my solution for this is 0, -3. Then I did the check and they both worked. Okay, so here is my solution for number 2. Number 3, when I took the second equation and solved it for y, I got this, y equals -6x plus 1. When I took that and I plugged it back into equation number 1, here's me substituting in for y. -6x plus 1 is the value of y. And when I did that, I got this true statement, 2 equals 2. And I want you to think back to when you learned about solving equations. And we had instances like this where every variable term would cancel out and you would just have a true statement. One number equals the same number. And when you had that, you ended up with infinitely many solutions. You also had an option sometimes where you had a false statement. Your variable terms would cancel out and you would get something like one number doesn't equal another number. For example, if I had 4x plus 2 equals 2 times 2x minus 3, 4x plus 2 equals 4x minus 6. When I cancel out or move my 4x's, I end up with a false statement, 2 equals -6, and that's not true. So this is an example of no solution, and it's going to solve the same way. You're going to get the same type of solution when you solve a system. Okay, so I just wanted to remind you what it looks like to have infinitely many solutions. One number equals the same number, a true statement. This means you get something that is true. And why is that? Well, that's because the graph of this system is a pair of lines that lay right over the top of each other. For number 4, y is already isolated. Y equals x minus 6. So I took equation number 1 and I plugged that in. So when I solved, I got x equals 3. Then I took equation number 2 and plugged in 3 for x, and I got y equals -3. So the set here, the solution to my system is 3, -3. Equation system number 5. So system number 5, both of these are solved for y. Y equals -4x minus 8, and y equals -8y, or 8x minus 20. So really what I want you to think about is I replaced y in the second equation right here with the expression -4x minus 8. When I solved it, I got x equals -3. Then I took the -3 and I plugged it into the first equation. And I found out that y equals 4. So my solution set is -3, 4. Number 6, again, I already have a equation that has the variable term already isolated, y equals -3. So I'm going to take equation number 1 and I'm going to plug in y equals -3 into that equation. And when I do, I find out that x equals -8. So then I'm going to take equation number 1 and plug that in. But do I need to do that? Do I need to prove that y equals -3, or don't I have it written right here that y equals -3? So the solution to this, oh, here it is the order pair -8, -3. Moving on to question number 7. Question number 7. So part of that got cut off. So this really says x equals -6y. So I solved for x. But as I solved this, I ended up with a false statement. I ended up with something that says -6 equals -2. Sorry, -6 equals +2. And that's not true. So that's an example of a no solution. Number 8, I took equation number 1 and I solved for y. That's right here. So then I took the expression 2x plus 10 and plugged that in for y into equation number 2. When I solved, I got that x equals -5. Then I took the fact that x equals -5, I plugged that into the original equation number 1, and I found out that y equals 0. So my solution to my system is the ordered pair -5, 0. All right, number 9, I can see that I've already got a variable isolated. I have the equation y equals. So y equals -6x minus 8. I'm going to take that and I'm going to plug that in right here for the value of y. So when I do that, I solve and I find out that x equals -2. And then I take the fact that x equals -2 and I plug it right back into the first equation. Y equals -6 times -2. And I find out that y equals 4. So my solution here is the order pair -2, 4. Number 10. So number 10 is interesting. I think I solved this kind of a tricky way. I'm glad that we're kind of reviewing this. So notice that both of my coefficients in my system are 6x. So what I did was I solved this first equation. I solved this first equation for 6x. I'm actually going to work this one out just so you can see what I did. I'm erasing it or whiting it out, actually, because this is a cool thing about using substitution. As long as you have, like, if you have the option to match up variable terms with their coefficients. So here's what I'm going to do. I'm going to solve this for 6x. I'm going to get this equation. So I'm almost solving for x, but instead I'm going to solve for 6x. And let me show you what that looks like. So first I add 6y to both sides. Can you please go shut that alarm off? 6x equals 6y minus 12. So then I take the fact that 6x equals 6y minus 12. I'm going to move that. I'm going to take that and I'm going to substitute it in right here. I'm going to substitute it in right here. So 6x minus 2y equals -16. But 6x is really 6y minus 12 minus 2y equals -16. 6 minus 2 is 4y. 4y minus 12 equals -16. And when I add 12 to both sides, I get that 4y equals -4, which means y equals -1. Then I took that y equals -1 and I plugged it back into the first equation. 6x minus 6 times y, which is -1, equals -12. 6x plus 6 equals -12. Subtract 6 from both sides. 6x equals -18. which means x equals -3. All right, so our last one, number 11, actually I think we have two. No, this must be the last one. So number 11, we are writing a system of equations for the scenario below. So the beach resort is offering two specials. The first one includes a 2-night stay and 3 meals for a cost of $195. And the second one includes a 3-night stay for 5 meals with a cost of $300. So it says find the cost of 1 night and the cost of 1 meal. So I let x equal the cost for the night and y is the cost for the meal. So for a 2-night stay with 3 meals, I pay $195. For a 3-night stay with 5 meals, I pay $300. And when I solve, I find out that a 1-night stay costs $75 and each meal is $15. A 1-night stay is $75 and each meal is $15. Now remember, this is a word problem, so when we have a word problem, we need to give a word answer. So 1-night stay is $75 and 1 meal is $15. Okay. All right, so that's the walkthrough on your homework, lesson 4.2. I just wanted to say thank you so much for giving me this opportunity to spend some time with my kiddos. I don't get to see my military babies that much. I want you guys to behave yourself, and I will see you on Monday.